Hello, this is Mr. Miller. We've learned quite a bit so far with adding polynomials, subtracting polynomials, and multiplying polynomials. Just want to do a quick review of these things that we've learned and also do a little bit of application. So when will we use these outside of just the standard equations? So I first want to start with a little bit of review on like terms. So we've got these up on the board, and we know that they have to have the same variable in order to have like terms. So this first one, 3 is a constant, 2x has a variable, so you can't combine those, they're not like terms. 5x plus 7x, they both got that x, same exponent of 1, so you can add those, equals 12x. X squared plus 2x, well, the exponent on this one is 1, exponents don't match up, so we can't combine those. AB plus BA, so they've got the same variables, they all have the same exponent, but they're in different order. Does the order matter when you're multiplying numbers? Is BA any different than A times B? It's not. So you could write 2AB or 2BA, either one. This next one, A squared B plus B squared A. This one could get a little tricky. All you want to really make sure you pay attention to, this squared is applying to the A. So that means that's A times B. So this, another way to write that is A times B. B squared A, well, the squared is on the B, so another way to write this one is B times A. Notice these two are not the same thing. Got two A's here and one B, two B's here and one A. So those are not like terms either. 3x squared y plus 4x squared y. Okay, same variables, x squared, y and a y. So if we've got 3 of those and we're adding 4 of those, we can say that we end up with 7x squared y. So 3 of those were like terms, 3 of those were not. And when they're like terms, you can combine them, adding them, keeping the sign in front. So combining like terms, you add their coefficients, but the powers, those variables and their exponents, those stay the same. Next thing I want you to look at, adding two polynomials. So let's say we've got 3x squared plus x minus 4, and we're going to add 5x squared plus 2x plus 2. So we should add those two polynomials. When we look at this, 3x squared, that's a like term with 5x squared. So let's combine those. It would be 8x squared, positive x, positive 2x. Those combine, add them, and they're plus 3x. Got a minus 4 and a plus 2. When we add those, you get minus 2. Next one I want you to look at, also adding polynomials. Z cubed minus z plus 1. We're going to add that to 2z squared plus 4z. So when we're adding these two together, same thing, let's look for any like terms. 7 or z cubed. There's no other like terms with that, so let's bring it down. Z cubed. 2z squared, I could write that one next. It's my next highest exponent. Nothing can combine with that. So plus 2z squared. So let's see, we've got a minus z and a plus 4z over here. When we add those, we'll get plus 3z. And then our last term, our constant, plus 1. You can tack that on the end. So this one, large polynomial's got 4 different terms. We were only able to combine the negative z and the plus 4z. Those were the only ones that were like terms. So you always want to watch out for those exponents. Make sure that they match up before you combine them. Alright, so let's move on to subtracting polynomials. Very similar, but only one additional step for these. So the second one is 2y squared minus 5y plus 2. So my suggestion when you're doing subtraction problems, this is what I do when I'm doing them. There's no distribution, anything to distribute in the front, so I'll copy this one down. This one, since you're subtracting that entire parentheses, you're subtracting everything that's in here. So if you change that to a plus sign, you can change the sign of everything on the inside. So what we're basically doing is we're taking this negative sign and multiplying it by all 3 terms on the inside. After you distribute, all 3 of these change signs. So negative times a positive is a negative, negative times a negative gives you positive, negative times a positive gives you negative. And then once you've distributed that negative sign, it's no longer there, so you've got that positive. Now we can go combine like terms. 5y squared, you can combine that with negative 2y squared. So you'll get 3y squared when you add those together. Minus 2y plus 5y give you a plus 3y. And then our last constants, plus 1 and a minus 2. When we add those together, you're going to get a minus 1. So subtraction, only additional step is to distribute that negative sign on the inside. Alright, I've got one more subtraction problem for you to try. Let's take a look at this one. Y squared plus y minus 5 minus 2y cubed plus 3y squared plus 4. So again, if you have a different strategy, feel free to use it, but I always distribute that negative sign and I change this into an adding polynomials problem. It makes it a lot easier for me. So y squared plus y minus 5. It's going to be a plus sign now because I distributed the negative sign to the inside. Alright, I've got all that distribution done. Let's combine like terms. So I've got a squared. I do have a cubed here. There's no other like terms, so let me write this cubed term out front. Done with that. Y squared minus 3y squared. So 1 plus negative 3 is going to be minus 2y squared. So we're done with those. Now we've got a positive y. There's no other like terms with that, so it's going to be plus y. and then we've got a minus 5 here, and a minus 4. So negative 5 plus negative 4 gives me this negative 9, or subtracting 9 on the end. You should have gotten that answer. If you're uncomfortable with any of these, please ask a neighbor, try and get some help. I'll be walking around to help you out. Cool, so that's subtraction. Moving on to multiplication. For multiplication, we do have two methods. You can either use distribution or you can use the box method. Personally, I prefer using the box method, but it's completely up to you which one you want to use. So we'll start with x plus 4, multiply that by x minus 4. So I'm going to set this up using the box method. This first term I'll write on the left side here, so x and then a plus 4. The second one I'll write up top here, x minus 4. Alright. So all I'm doing is finding the area of each of these 4 boxes. So this one, x times x, I'll get x squared. This one, x times plus 4, I'll get a 4x. This one up here, negative 4 times x will be negative 4x. Down here, negative 4 times positive 4 will be negative 16. From here, I want to combine like terms. These two terms happen to have the same variable to the same exponent. When you add them, 4 plus negative 4, you get 0x. 0 times anything is 0, so you don't have to write it. All I'm left with is my answer of x squared minus 16. Next one I want you to try out. X minus 3 times x minus 3. So again, I'm going to do the box method. Completely up to you if you want to use the distribution method or not. I've got an x and a minus 3 here. I've got an x and a minus 3 here as well. Alright, so I want to find the area of those 4 boxes. X times x gives me x squared. X times negative 3, negative 3x. X times negative 3 over here, negative 3x. And then negative 3 times negative 3 gives me a positive 9. Again, I'm going to combine like terms. I'll keep my x squared out front. Negative 3 plus negative 3 gives me a negative 6x. And then I'm left with my positive 9 on the end. And there you have it. You should get the same answer whether you're doing distribution or box method. So you could try both and see which one works out better for you. Or just make sure you're getting the same answer as everyone else, even if they're doing a different method than you. Alright, 5x plus 1 times 2x minus 3. So I'm going to do my box method, 5x and then a plus 1. Split those terms up, 2x minus 3. Alright, so this first box will be 10x squared. Multiply the coefficients, multiply those variables. 5x times negative 3 is negative 15x. 2x times 1 is 2x. And then negative 3 times 1 is negative 3. So again, combine those like terms. I'll keep my 10x squared out front. Negative 15x plus a 2x is going to be negative 13x. And then keep the minus 3 on that back side. Alright, actually we've kind of got 2 more. But one more of these binomial by a binomial ones. So we've got a binomial 3x plus y. We're going to multiply that by x minus 3y. So I'm going to split up my terms, 3x and a plus y. Split up my other terms, x and a minus 3y. Alright, so 3x times x gives me 3x squared. 3x times negative 3y. Well, the coefficients come out to negative 9. X and y, they're not the same base. So you just write both of them, x times y. Negative 9xy. X times y is just xy. And then negative 3y times y will be negative 3y squared. So combine any like terms. We've got these right here. We'll keep our 3x squared out front. Negative 9xy plus 1xy is going to give you negative 8xy. And then keep the minus 3y squared on the end. These might be a little bit different because you've got two variables, but you can roll with it. X times y, good stuff. This last one is a binomial times a trinomial. So 3x minus 2, we're going to multiply that by x squared plus 4x minus 1. Again, you can use distribution method. I like the box method, so I'm going to show you that way. If you do want to see me do the distribution method, just let me know. I can do that for you as well. Split up these two terms. So 3x minus 2. I'm going to split up those three terms. X squared plus 4x minus 1. So this is just going to be a little bit larger of a box. We're still going to find the area of each of those boxes now. We just have a little bit more to do. 3x times x squared is going to be 3x cubed. Negative 2 times x squared. Negative 2x squared. 3x times 4x gives me 12x squared. Negative 2 times 4x is negative 8x. 3x times negative 1 is negative 3x. And then negative 2 times negative 1 gives me a positive 2. So you're just going through each box individually and finding the area. So multiplying the top times the side. Combine any of those like terms. We've got two pairs of like terms in here. So I'll keep the 3x cubed out front. Negative 2 plus 12 gives me plus 10x squared. Negative 8 plus negative 3, negative 11x. And then you've got your plus 2 on the back side. Alright, cool. So that's it for the review on adding, subtracting, and multiplying. Let's move on to a little bit of application. So you can start reading this problem that you see on the screen. Alright, so we've got a yard, a square yard, and the side length is 5x plus 2. So here's my square yard, 5x plus 2, 5x plus 2, okay? And I've got a pool, so my pool's on the inside somewhere here, and the length is 2x plus 1, and 2x plus 1. That's my diagram. So the perimeter of the yard, if you finish labeling all these sides, all you got to do is add up the entire perimeter. So 5 plus 5 plus 5 plus 5 gives you 20x. 2 plus 2 plus 2 plus 2 gives you 8. And that's your perimeter of the yard. the area of the yard, when you're multiplying 5x plus 2 times 5x plus 2, so I'm going to do area of yard. You should be able to multiply that out and get 25x squared plus 20x plus 4. Area of the pool, well, 2x plus 1 times 2x plus 1. Use whichever method you prefer, and you should be able to get 4x squared plus 4x plus 1. So when it's asking you to find the area of the yard where the grass can go, it's asking you to find this area right out here. Using the information we already know, you can take the area of the entire yard, and all you got to do is subtract out the area of the pool. So the large area, subtract out that smaller area, and all you're left with is that outside part where the grass can actually go. So all we're doing is taking the area of the yard. Let me just do some place at the perimeter. So we're going to take the area of the yard, and we're going to subtract the area of the pool. So we know the area of the yard is 25x squared plus 20x plus 4. And we want to subtract the area of the pool, which is 4x squared plus 4x plus 1. From there, you just got a simple subtraction problem. I'm going to distribute that negative sign. 25x squared plus 20x plus 4, and then it's going to be plus a negative 4x squared minus 4x minus 1. That's after the distribution of that negative sign. Combine like terms, 25x squared, negative 4x squared, that's 21x squared. Our x terms, 20x plus a negative 4x, it's going to be plus 16x. And then we've got our plus 4 and our minus 1. So we've got a plus 3 on the end. So we just did that step by step, finding the large area, finding the smaller area. Take that large area, subtract out the small area, and you're left with just the area of that yard. Alright, so here's a similar situation. You decided you didn't want everything to be square. So we've got some rectangles involved here. Plus, you want a shed. Things are getting real. So let's see if you can draw that diagram. Label the diagram. And let's get going. Alright, so you've got a yard. The length is 2x plus 5. The length here is 2x plus 5. The width is 7x plus 2. So to find that area, you could just multiply those two polynomials and get your answer. Let's see, the area of the yard. You should be able to find that. We can also put the pool in here. So the pool, we've got x plus 1, and it is still a square. So x plus 1 times x plus 1. And then you've also got your shed somewhere down here. And the length of that is x plus 1 times x plus 2. Yours may or may not look exactly like this, but it should be pretty similar. You can go ahead and find the area of each of these. When you're looking for the area of the yard with the grassy area, you're just looking for this shaded region on the outside here. So you can take the area of the yard minus the area of the pool minus the area of the shed. So that big old area, subtract out the area of the pool, subtract out the area of the shed, and you'll be left with that shaded region. So go ahead and see what you get with that. Challenging problem, but it'll be good times in the end. Let me know if you got any questions, and hopefully you enjoyed. Adios.